In this video, I'm going to talk about how to calculate sample size when estimating the sample mean with a given standard error. So let's read through this example. Previous studies of the height of men in a particular village have found that the standard deviation of the heights are 14 centimeters. Okay, so let me go ahead and write that down. So if X is the height of the men in this village, then sigma X is 14 centimeters. The standard deviation for the height of these men is 14 centimeters. Okay, let's continue reading. A researcher wants to take a sample of these villagers and find their average height. Okay, so she wants to find X bar. Okay, suppose the researcher wants the standard error for her estimate to be no more than 2. Okay, so remember, standard error is the standard deviation of X bar. Okay, so the standard deviation of X bar, the standard deviation of the sample mean. That's what standard error is, and she wants it to be no more than 2. So I'll go ahead and set it equal to 2. Okay. How many men should this researcher sample? Okay, basically, what should her sample size be? All right, we know from the central limit theorem that sigma X bar, the standard error, or the standard deviation for the sample mean, equals sigma X divided by the square root of n. Right? This is an algebraic equation, and can I solve this for n? Yes, absolutely. I could start by multiplying both sides by the square root of n, and the square root of n will cancel in the denominator, and I'll be left with the square root of n times sigma X bar equals sigma X. Okay, then I could divide both sides by sigma X bar. All right, and these guys will cancel, and I'll be left with the square root of n equals sigma X divided by sigma X bar. Okay, square both sides to get rid of the square root symbol, and I'll have the equation for n, which is sigma X divided by sigma X bar squared. All right, so now I just need to plug in what I know into this formula. All right, so looking back to what I was given, I'll have n equal sigma X, or the standard deviation of the heights, is 14. The standard error, I want it to be no more than 2, and I need to square it. All right, so 14 divided by 2 is 7 squared, which is 49. So this researcher should sample at least 49 people so that her standard error is no more than 2.